All right, so good afternoon, good evening, everybody. Today's mini lesson is going to be on for graphing inequalities. That's what we started today in class. Today is October 15, 2018. So just as a recap for vocabulary, we talked about systems of linear inequalities, where it is a set of two or more linear inequalities in the same variables. So just as a reminder, make sure that you have that it can be two or more linear inequalities in the same variable. And just as a recap, don't forget your inequalities are going to be any greater than, less than, greater than or equal to, or less than or equal to sign. That's going to be your examples of your inequalities. Okay? Now, what I'm going to do, because this is a video, if you don't understand something that Ms. Gable is saying, what I want you to do is pause it. You can turn on closed caption. Feel free to rewind as much as you need. And also you can slow down the pacing of my voice if I'm talking too quick. Another vocabulary word we reviewed in class is a solution of a system of linear inequalities. And what that is just an ordered pair that is a solution to each inequality in the system. So do be reminded that an ordered pair is written in the form of x comma y. So it's going to be a point. And then also it has to be for each inequality in the system. So meaning if you have two inequalities, you got to have true twice in order for it to be a solution. If you have three, then you have to have true 3 times in order for it to be a solution. Take a second and write that down if you don't already have it written down. So for practice, what we did in class is look at, it says determine if the ordered pair is a solution. So what's going to happen is -2, -1. I'm going to end up substituting that in for every single x and every single y that's given inside the equation. So the very first example is where I have y is going to be greater than 3x. Where there is a y, I'm going to plug in a -1. And where there's an x, I'm going to plug in a -2. So what's going to happen is I have a -1, and it has to be greater than a -6. Now, on a number line, -1 is greater than a -6. Okay? It's better to owe $1 than to owe 6. So this example is going to be true. What I want you to do is try the next two. So for the y, you're going to put in a -1 here, in here, and for the x you're going to substitute in a -2 for x here and here. Okay, so go ahead, pause the video because I'm going to write it down in a second and be right with you, because we need to determine if this ordered pair is a solution to this whole entire system of inequalities. So I need to see 3 true solutions, or three true examples. Okay, so what I have for you here, I worked out the examples. This one here for y, I plugged in a -1, and here I put a -2 for x. Now, -1, this says has to be less than or equal to a -4. Now, -1 is not less than a -4. -1 is actually greater than a -4, and for that reason, I have a false statement. Now, that one false mean that I did not have to do this equation at all, because as soon as you get a false answer, what happens is -2, -1 is no longer a solution. Okay, now this is what happens when we are checking to see if an ordered pair is a solution, yes or no. Okay, take a second and write it down. Now we want to see if the point 0,4 is going to be a solution to the system of linear inequalities that we have here. So once again, for every single x, I'm going to plug in a 0. And for every y, I'm going to substitute in a 4. I need to say substitute. Pause it for a second, and I want you to give it a try. And then I'll come back with the final answer. Okay, so what I hope you found out is that if you were to plug in a 4 for y and a 0 for the x value, the first inequality where y is greater than 3x, you came up with 4 is greater than 0. That one is true. But on the next inequality, y is less than or equal to x minus 2, a 4 for y, a 0 for x minus 2. So you came out with, as a final statement, 4 is less than or equal to a negative 2. That happens to be false. You can stop right there because 0, 4 is also not a solution. So as soon as you get a false, you can stop. It's not good, but we can go ahead and we can move on because we know that in order for a point to be a solution, it must be true for all three or for all of the given inequalities. So for that reason, this one won't work. Now, if you really just need to see one way it works, just ask me in class and I'll give you an example. Okay, so take a second and write that down if you need to, and if you have questions about it, I'll be available in tutoring this week. Let me know. For the next example, what I want to do is actually graph a system of linear inequalities. So we're going to start kind of with some things that we already know. So the first inequality is y is greater than or equal to a negative 4. So what happens is here, my line where y is equal to a negative 4 is going to be a horizontal line. So I'm going to start from the origin, which is here, and go down 1, 2, 3, 4. And so now I have a point at 0, negative 4, okay? And it doesn't matter what the x values is on this line. That doesn't matter. This is the line where no matter what, y equals a negative 4. So what that line is going to look like, oh, this is kind of ratchet, using a fingernail file. It's going to be a solid line, and my reason for the solid line is because I have a solid line underneath my inequality. So this line right here, and I like to write it on the side, is going to be the line where y is greater than or equal to a negative 4. So what's going to happen for this line, when I shade it in, is the solution to that one line is this entire section here. Okay, so I did kind of like a zigzag line. If you want, tomorrow we're going to use highlighters to do this part. Okay, so give me a second. I'm going to write down the second inequality that's going to go on this exact same graph. Okay, so this one here, y is less than a negative x plus 2, what we discussed in class is that we following slope-intercept form. Okay, and so what happens is here, the number in the place of m, or the coefficient on x, is a negative 1. And the coefficient of b, or I'm sorry, the constant b, my y-intercept, is going to be 2. Okay, so I wanted to make sure we were on the same page with the graphing part. So what this means is that b is negative. B equals 2. See, because it's positive 2. So what that means is that I'm going to start from the origin and go up 2. So 0, 2 is that location right there. Okay, and so then my slope is a negative 1. So what that means, I can rewrite this fraction as negative 1 over 1. And to be honest with you, I can rewrite this 2 ways. That same negative 1 can be rewritten as negative 1 over 1 or 1 over negative 1. You can use any one of those to find your slope, because remember, the slope is the rise over the run. So this tells us, do we go up or down on the top number, and then the bottom number lets us know if we go left or right. Okay, so here we go. I'm going to start at 0, 2, and from there, if I apply this slope of negative 1 over 1, I can go down 1, and then to the right 1. Down 1, right 1. down 1, right 1. Okay, and since this inequality does not have a solid line underneath it, when I draw my graph, it is not going to be a solid line. So here is what it's going to look like. Oh geez, this is not an ideal ruler. Y'all like our rulers? I do, but it's okay. We're going to make it do what it do. Okay, so that's going to be the line, and let me be a little specific. This is my line where y is less than a negative x plus 2. Okay, and since it is less than, okay, this line is going to include, let me go to one of these. I don't think you can see it. It's going to include all the values where we are less than this line. Okay, now already from the line y is greater than a negative 4, we shaded above all of this section here with the zigzag line. Okay, so that's going to be all of what you see highlighted right in here, because that's highlighted and squiggly line. That's going to be part of our solution. I got one more to go. Okay, so this is our last inequality. So we started out with y is greater than or equal to negative 4, and then we went to y is less than negative x plus 2, and then our last inequality is y is less than 2x minus 2. So what happens here, B, our beginning, our y-intercept is a negative 2, and our slope is a positive 2. But don't forget that positive 2 can be rewritten as 2 over 1. And we would apply that same rise over run. So we got a positive 2. That means we're going up 2. And we got a positive 1. That means we're going to go to the right one. So let's go ahead on and start plotting those points. And I'm going to do it in red so we can see a little bit better. So what this means is I'm starting at a negative 2. From the origin, 2 down, 1, 2. Here is my point. 0, negative 2. And my slope, sorry about that, my slope is going to be up 2, 1, 2, and over 1. So I have a point at 1, 0. If you want to write that down, and then I can go up 2 and over 1. So I now have a point at 2, 2. Okay, y'all, so all I did was continue drawing in the line here. I connected my points, 0, negative 2, 1, 0, and 2, 2. And I drew in my line for the graph y is less than 2x minus 2. And so I wrote down the equation or the inequality for that graph there. And what I want you to see is that this purple line here, or the purple squiggle, and the yellow dashes, the less than side, I can draw arrows going straight down. And this is going to be my inequality for y is less than 2x minus 2. So where does all of this fit in? You see this section right in here where all of the lines intersect? That little triangle right there, that represents the solution to the system of linear inequalities. So any point that falls within that section will be a solution. And that's really everything that we did today in class. So if you missed it, then of course ask questions, come to tutoring. I will be available this week. I wish you all the best. Ms. Gable loves you. Have a good night.